We were supposed to, but unfortunately Father John's class is in there because he's over there in the meeting. We're having a meeting over at the convent today. This child, Father John, there's not a bunch of stuff. So his class had to use it because they needed to watch videos in their class. Nobody's in there. So I went down there to observe it, and they told me no. So.
What are you talking about?
We might be moving over there in like a few minutes. There's a sub in there that's probably bringing them over in like 5-10 minutes.
Bring them over.
The library's taken. We were going to do a lab today, but it's not a problem. We'll do something else. We'll do it next week. We have time. Okay, it's no difference, guys. We'll get to the lab. We'll definitely do it. Say out. Say out. What are you guys doing?
I just have to see if we're going to see the full podcast.
It's got to be done with this.
Did you mind back?
Oh, maybe. Maybe
Did that go in?
it's short. Okay.
I should have done it together, but I said this was going to print it.
All right.
You said I should have done it today.
No.
Please write, people.
Oh, but guess what? Oh, man.
That's like a flag after party. Why don't you sit there? I can't sit there, so that's what makes me too sad. We should have heard the James Southern accent. Talk to him already Hamlet.
During the whole part two, act two, we had like 5 different accents.
Really?
But it's just everything all such.
So, what we're going to start today is a topic called calorimetry. And it sounds like calorie for a reason. It does. It absolutely does.
The Spanish word for.
Hey, what is it?
Wait, what? Hello?
Calor, yeah.
Means.
When you're hot.
So, the term for, you know the term we use, joule for energy? Joule, okay? Joule is named after a person. You know how you hear the term calorie when you look at food? How many calories are in it? Calories are just energy units. That's all it is. So it's amounts of energy in the food. That's what a calorie is, really. So technically, that's why people do those things where they have calorie balances in their diet. So if you intake 10,000 calories, which is a crazy amount, it's a very large amount, but if you're able to exercise enough all day or burn about 8,000 off, then your overall intake for the day is just 2,000, which is what your regular diet should be.
What's that swimmer that called smoking weed?
Yes, Michael Phelps.
Yeah, he took like 20,000.
Michael Phelps, yeah.
But he used to burn them.
He would ingest over 20,000 calories of energy a day in food. But because he swam so much, he burned it all off.
Freaking insane.
Yeah, so if you ever hear the term before, and this is something that would really help you guys, especially going to college, if you don't want to gain those freshman 15 or so.
I heard it's 30.
I heard it's 30 minutes. Here, what I would recommend is this.
30.
This is what helps a lot of people. If you're able to, one, you need several things in your diet. First, you need to keep active. You can keep active, guys. You're able to burn all the calories that you ingest. That's one thing. So, don't sit in your room all day, playing video games, go out, play sports, go for walks, go for hikes, go camping, canoeing, mountain climbing, skydiving.
Where do we have a mountain?
You want them to
You lose potential energy though when you skydive. So you're losing energy still.
Yeah, but not.
No messing. All right, so that's one thing. Two. If you guys want to really keep something like your metabolism up, what you really want to be doing is eating small meals throughout the day in little portions. So instead of eating like just breakfast and just lunch, or just lunch and just dinner, which a lot of people do. A lot of people do that. You want to really eat many small meals, so like every 3 hours, have a
That's what I
meal.
do.
Every 3 hours, so for example, break, you should definitely bring food for break every day. You should always bring food for break. You should have, if you have food before school, food at break, food at lunch, food after school. 4 small meals, and that's already only like 3:30. Okay, then you could have like a smaller dinner and then a later snack. But you don't want to eat something before bed, you know that one, right?
Yeah.
Okay, because it's your you don't burn any of it all.
Oh.
It's automatically not going to be good for you.
Sometimes I wake up like at 3 in the morning just to go eat.
That's
Like,
not good.
I might go to sleep like at 9, but I wake up like at 3 and go eat.
And
But I'm
sometimes you have
sleeping.
those urges and whatever, that's not a big deal.
That's a good thing.
Yeah, but you don't want to do it every night.
I wish I
You
could.
know, you don't want to eat and then go right to sleep, because anything you eat is just going to sit in you, and it's going to eventually turn to fat. If you can burn something off, it'll actually burn off, and most of it'll turn to muscle. Right now you're not. Right now you're not. But you need to. I'm just telling you that again, you don't have to do anything about your metabolism right
Can
now.
you get like rolling
You're not in here. Can you be in this class and anatomy, or is that at the same time?
No.
You can't.
Mark would know.
I was wondering if somebody was in anatomy. to do
No, that's fine. We're in here, we can't.
Now,
That's why my kids didn't take AP.
the thing about eating late, guys, is it really is serious. So yesterday, my dad or my mom called me yesterday afternoon, and my dad unfortunately went to the hospital yesterday. So he was in there overnight. He went in because he had a problem with his arm about 3 or 4 weeks ago, where he couldn't move it at all. He's owned a deli for 30 years, this deli, and he owned another deli for 10 years. So he's been working as a deli for 40 years. But it's a lot of work. You're slicing every day. You're constantly moving around. Maybe he's cleaning a lot. So he works about 85 hours a week. So yeah, it's a lot of work, absolutely, when you're in your business. But the other day he started hurting, maybe a few weeks ago. So he started taking some sort of anti-inflammatory, because some of his tendons and muscles were inflamed in his arm. So he couldn't even move his arm. Like he couldn't take his shirt off by himself. It was really bad. So he started taking a bunch of different things. He had to get cortisone shots. And about 2 days ago, he started feeling really bad chest pains. Like to the point where he was like, I don't know what's happening, you know? So my mom had him go right away to the hospital. And what they noticed was they did what's called a nuclear, I don't know why they call it, I know why they call it nuclear, because they're using some sort of radioactive isotope to track your flow of your blood. What they do is they put a radioactive isotope in your bloodstream, and they can follow it with a tracker. And they can see if you have any cloggages in your arteries. It's a new way they can check for clogged arteries instead of actually going into your body and searching everywhere. Some invasive surgery. So what they noticed was they had 2 arteries that were clogged. One of them was 99.97% clogged. So they said, like, if you look at an area of a cross-section, there was a little spot where the blood was going through, like a little spot. And another one was 85% clogged. And one of the things they said to him right away, they obviously operated right away and they fixed it. They put what's called a stent in. I don't know if you've heard of this before. It's like a little balloon. They put it in your artery and it makes your artery expand so they can clean it out and clear it. And then after that, your artery's nice and clean. But this stuff doesn't usually get detected right away. So thank God they detected it. But the one thing they said to him was what I just said was, do not, and he does this a lot, he eats food before he goes to bed all the time. And I mean, like, my dad goes to bed at like, I don't know, like 11, and he gets up at like 4 every day. That's his hours for sleep. And I would say that at like 11, maybe 10:45 every night, he eats either like a half a pint of ice cream or like chips and other stuff. And he's been doing better with like pretzels, but he's always done this for like 25 years. And they said right away, they were like, that's one of those things that people don't notice. And like he even has a bit of a, you know, but it's not beer. He doesn't drink at all. He doesn't drink any alcohol actually at all. So he has a bit of a belly, but it's not for that at all. And that's the first thing they said also, like you're going to notice that that's going to be something that's going to start, you're going to start hurting your back from that and stuff too. So don't eat right before you go to bed. That was the one thing they said in his diet, that's the worst thing. Because everything else is okay, because he eats a lot all day, but he's on his feet for 10 hours a day, so he doesn't have a problem with that. It's the fact that he's eating before he goes to bed and it just sits in your body. So keep that in mind, guys, really do. It really is tough though, because I know when you're working and you're up late, right, in college especially, you're going to notice this. For 4 years I remember, I'd be up till like 3 in the morning just doing some study work and stuff, because you don't have class until like sometimes noon the next day. So you stay up late, and some people are night owls, and I always have been. I guess still am. So I always like to do my work really late. But then when you're doing work, what do you want to do? You want to eat some food, drink maybe some coffee or some soda, stuff that you really shouldn't be doing late. So try to stick to like tea at night. Even if there's caffeine in it, it's okay, but it's better than coffee. Even if you want some caffeine, do some tea with caffeine, not coffee at night. Don't do soda at night. It's going to rot your teeth, one, and two, it's just bad for you. Carbonation, all the sugar in it, it's going to be your stomach hurt the next day.
What about juice?
Juice is great. I drink like all the Dole juices that are 100% natural. I get those all the time. Even the ones that are frozen, you put in the freezer. Yeah. Take them out, put them in the fridge, mix it with like a half a gallon of water, and you're good to go. That's the best stuff. White grape juice is really good.
Like regular juice?
Oh, so you like orange juice? Yeah, like pineapple juice? Yeah. But don't drink stuff from concentrate. Drink real natural juices. Because all the other stuff is added sugar.
So like this, like roaches and stuff, that's not good.
What's not good?
Roaches.
Welch's is great.
Welch's is
Just read the label. The label on Welch's says 100% natural. That's my favorite. I get the white grape peach from Welch's all the time. My favorite.
100% wholesale. It only has to be 50% wholesale. 100% like bread, for example, like the restrictions for certain things, like to be labeled like whole wheat. Doesn't necessarily have to.
Doesn't mean it's 100% whole wheat. Of course not. That's different. But the juices that say 100% natural juice, they are 100% all natural. It's juice, it's actual fruit, crushed up. They take the juice, they freeze it into a solid, and then you defrost it. That's what you're getting.
We're talking about ones like the cans or like
yeah, in the actual cans that are actual natural, they really are.
I was like talking like
Well, it depends. It depends, guys. If you get Tropicana, a lot of those things are mainly all natural, but there is some added sugar in there. If you can get like real fresh squeezed orange juice in a store, you're gonna pay a lot of money. I mean, they have these things, you know, that you can actually do your own. You can buy your own. You cut them in half, you put it down. It's a juicer, but they have the automatic ones too. But it's specifically for orange. It's not juice. Yeah, they have a juicer. That's the ones you put like. You can put apples in there, strawberries, anything in the juice. I mean the ones that are just for orange, like orange. I see a lot of old ones in Italy and stuff, and other countries in Europe. That's what you say. Anyway, back to calories. So, it's a good conversation to have.
Mr. How you talking about one of those juice machines you buy and take home, right? You wasn't talking about
Either way, the one in the stores, you put the orange in and they squeeze it for you. The one you bring home, traditionally, it's like a hand press one. Right, you can buy the automatics for home, but they're just expensive.
You talking about I can go to the store and make my own orange juice.
There are some stores that will make you fresh squeezed orange, sure.
No, I can't.
So you put it in a machine.
If you buy a machine, you can at home. In the store, they do it for you. Exactly. Guys, why are we arguing about this? Who cares? Either way, drink all natural juice.
That's the whole point.
The point is not to argue. The point is to agree that we should drink healthy stuff.
At the same time, he said juice, but he won't talk it out.
Whatever, you two just want to argue with each other. You're like, brothers, stop. So, the first used experiment to determine, first used to experimentally determine the specific heat. So, remember these values? The values that we've been talking about, the C value. So the C value last night that you used was 128. It was aluminum, remember that? Okay, or the C value of water or ice or steam. These are all values that are just on a table, but the question becomes, where do they come from? And it's such an easy experiment, and you're going to see it's like, I mean, it's so invented at the same time now. It's simple as anything. Remember the other day when I had you guys put your hands in the cold and hot water, and I put them in the lukewarm water? You felt what happened? Okay? Now, the whole idea of this one is, do you want to explain? Because your explanation was pretty good. Do you remember what happened?
Yeah, it was like,
Give me your overview, then I'll comment after.
like one side taking on both hands and put them into the warm water. At first it was like, I didn't really feel anything for like a quick moment or two. It was just like, it was weird, like the water was kind of flowing through you. And then I started.
Like you're numb almost?
Yeah, almost numb. And then it was like, after that, I could feel the difference. Like the heat was leaving on my right hand, which was the one that was in the warm water. And I could feel like the heat from the water going into like the left hand.
So you feel the reverse. That's pretty much what happens. So here, you have a cold hand and a really warm hand. When you put them in lukewarm water now, or room temperature water, the cold hand draws heat in. So it'll suddenly start to feel hot. The hot hand loses heat because there's so much heat in it and you're in lukewarm water, so it starts to feel like it's cooling off. So you feel the reverse. That's the cool part. So your hand will feel cold here and hot here. Then you put them in and you feel the reverse. But it takes like a good 5 seconds. Like at first it's just going to feel numb, and then it'll start to actually reverse itself. That's the cool part I was trying to get at there. Yeah, Christian had a good written explanation there. So, the idea of that gets carried over into calorimetry. So imagine if you took something that was really, really, really hot. Like you're taking a sword, you're what was it called, blacksmith? A blacksmith is making a sword, he's pounding out the metal with his hammer, it's really hot, it's heated up. He takes it and he quenches it, or he puts it in really cold water, right? You start to see all the steam come out. So what's happening there? Who can explain what's actually happening? Julie?
Well, what's happening is, like, the heat is being transferred to the water.
Very good. That's exactly it. It's exactly what I wanted to hear. Perfect.
Exactly.
The heat from the sword is being transferred into the water. There's no coolness from the water going into the sword, right? Remember, heat only goes from hot to cold. So what he said is exactly right. The hot object, so the sword that is heated up, that's getting put into the bucket of water, the heat is coming from the sword into the water. That's the key point here. There is heat coming from the sword into the water. Now, over time, as T goes to infinity, the end behavior, what will happen to these temperatures? They even out. We talked about that. What do we call that? One word? Equilibrium. Very good. Equilibrium. So, if we can use the idea of equilibrium, we can figure out, because we know the specific heat of water, that was one of the things that we did know, we're able to determine, we can figure out the specific heat of this unknown metal based on how much energy flows in and out. And we can do this based on the calculations we've been using with Q equals mc delta T. We're not phase changing anymore. We're not phase changing. It's a solid and it's remaining a solid. It's just going from a really hot solid, and over time, it becomes a really cold solid. Or it comes to a temperature that is in now equilibrium. Okay, and this is what you see when they make the sword.
Does that make it stronger?
It also does make it stronger. Now, the rate at which you cool something affects its physical properties and the way it will form a lattice versus another type of structure. I'm not too good at materialist science. I know enough to know that when you quench an object, it does make it stronger. It does. It makes it less brittle. Okay, that's why they take the sword, they dip it in, and then they pull it out. Okay, they let it cool off and they take it out. It won't crack when you're using it. Not to mention, the swords were made from materials that were not brittle. Like, for example, would you take ceramic and make a sword out of it? You take a ceramic sword and swing it at one object, what's going to happen? It's break instantly, because ceramics are very brittle, whereas metals like steel are very malleable. Okay, they're not brittle, they are ductile, in other words. Ductile means they can be formed, just like malleable. Okay, it has to do with ductile strength. Anyway, so the idea is that if we know how much heat is flowing in and out of this, we can then figure out what is the specific heat of this unknown metal, or whatever this metal is. Okay? And you know what else is really cool? We learned earlier in the year, and we talked about it, actually I had you guys read this if you remember. There was an article or an excerpt in your book, and what it had in it was the idea where they measured King Herod's gold crown using density to see if it was actually made of pure gold or if it was an alloy of gold and brass. And what the scientists, I think it was Archimedes, was it? Or was it Archimedes that did it or no?
I think so.
Who used? I thought it was Archimedes. Anyway, what he measured and what he determined was, based on the density of the metal, he was able to determine that it was not pure gold. It was gold and brass. So the king was swindled, and they used that. You could do the same thing here, because if you're able to figure out the specific heat capacity of pure gold, if you could heat it up enough without it melting, and then quench it, see how much you get, or see what you get for the specific heat value. If it matches gold, it's pure gold. If it doesn't match gold, what do you mean? It means that they mixed something else in it, or they polluted it, right? They polluted it, or it became a less concentrated solution. Just like, think about things, and this is a real thing you guys have to think about. I know a lot of people, I know you guys have, had parties and stuff, and people around you sometimes will be doing drugs. One thing that a lot of people don't ever consider is stuff that like mixing. People especially, they get involved with things like cocaine. It's very unsafe, not to mention it being a drug, but it's unsafe for many reasons. One of the biggest things about that kind of a drug, or any drug, is that they can mix it. It's called cutting it up, which many of you guys have heard that before. If you cut a drug, it means they'll take even something like flour to mix it in with cocaine. And people will think that they're using something that's pure. And what other people do that are, obviously either way, a drug dealer is not a good person, but a worse drug dealer would make something in that causes people to get a different kind of high, but it could actually kill them. So there's been stories of people mixing in anthrax with cocaine, and people dying from this stuff. So not to mention drugs are bad as well, but think about what could be in there that you don't even know. You have no idea what's in there. You have no clue. Anybody can disguise something. There are many ways to do stuff, guys. And if you ever, there's a book I would love you guys to read. If you ever have some free time in the summer, read the abridged version of it. The original version is like 1,200 pages. The abridged version is only like 500. Have you ever read The Count of Monte Cristo?
Yeah.
You read it? How good is this book?
It's amazing. It's like,
Isn't it amazing?
yeah, it's
Such a story. And one of the things in the story, do you remember with the poison? And how he builds up an antidote strength for it? So one of the main characters, and I'll give you this excerpt, it's not going to ruin the book, but his name is Alexander Dumas. And what he does is, he's able to develop an immunity to a poison by slowly poisoning himself more and more every day.
Isn't that how most
Not Alexander Dumas, Dante's, Edmond Dantes. Sorry, Alexander Dumas is the author. And that's exactly, Karen, you want to explain that?
No, don't
Vaccine, you said that's how vaccine works, can you explain it?
Basically, like any kind of medicine, to be
Okay,
honest, they basically put the same disease in it itself, so that you're immune to it, so you know what your body responds to.
But it's a weaker form, that's the key. They can't give you the disease itself, because then you get it. They give you a weak form of it that is not going to affect your body, so your body knows how to react next time the same kind of disease comes in, and now you can fight it off. So what he does, do you want to explain what he does? Do you remember, or do you want me to? Anything? Every day, what he does is, he takes a poison, but only a non-lethal dosage. So imagine if 10 milliliters of this poison would kill you, he takes like 2 the first day. And he takes 2 the next day. But then he does that for a week. Then the second week he takes 3 milliliters. Then 4, and I'm not saying this will work, so don't do this at home, please don't do this. But the idea is that he's using, for example, almost like a less concentrated version. He puts 2 milliliters of poison with 20 milliliters of water and drinks it as a less concentrated version. Then he does 4 milliliters with water. Then he does 6 until it becomes more and more concentrated, so his body builds up an immunity. So at one point in the story, he's able to use this poison on his enemy. And his enemy will say, you drink it first, because he gives him a drink. And he's like, sure, I'll drink it first. He doesn't die. He gives it back to his enemy, and what does the enemy do? To trust that it's good, he drinks and he dies. It's exactly right. Okay, but the idea there is concentration. Just like the idea with the drug. If a drug is more concentrated with something that's versus being diluted, same idea with this metal. Okay, it can be diluted with impurities, with things like brass and copper and nickel and aluminum instead of pure gold.
You said the first name was Archimedes?
I think we thought. Let me look it up. Hold on, I'll tell you right now.
Yeah, no, that's Archimedes.
Do they say it's Archimedes in the book? Yeah.
No. Ain't that talking about the year like that whole story, but right? It's like around. I don't know, how do you get the drug?
It's not listed as Archimedes, but it has to do with all of Archimedes' principles. I think that's why we thought of that, or I thought of that.
You talking about Archimedes, but actually.
Okay, so as we all know this, Archimedes' principle was simple. When you put your foot in water, or something in water, the water level rises. It's displacement volume. They used that to determine the thing with the crab. It was not Archimedes that did it, or it doesn't say whether it was.
But are you talking about the crab and stuff? I'm a dead.
Let's talk about the crab, yeah.
Cause this is niggas.
All right, so let's get into calorimetry.
Byron, what is it called?
It's like no good.
Yeah, I don't want to. Who else in my side? Specific name?
We got a quiz today?
Yeah.
On who?
It's on.
Didn't work.
All right, so that's what we have to start with. We're going to quickly, and we're not even doing a derivation, it's like 2 lines. That's it. So we start with the idea that the amount of heat that comes out of the metal into the water can be thought of, even though it's not mathematically right, because we know heat only goes from hot to cold, can be thought of as the negative value of the heat, or the energy change, we'll say now, because now it's not really heat. The energy change from the water into the metal. And that's logical. Think about it. As opposed to something getting colder, now it's getting hotter, it's the negative. You're losing or gaining heat. Okay? So we think of this, okay, as heat going from metal to water. We think of this as the water, okay, giving the negative amount of energy in the other direction. Which is kind of weird to think about. So, we say, I should put subscripts, but I'm not going to, just because it's messy. All right. For this kind of a problem, we have to think about the fact that we have metal and we have water, one on each side. So on this side, let's determine the properties for metal and see what happens to the metal. On this side, let's see what happens to the water. But remember, the way we used this formula originally was determine this value right here. That was the original reason to use calorimetry, to find the specific heat capacity of the unknown metal. Okay? Of the unknown metal. So this is going to be water, whatever water's value is, which we know. This will be the amount of water in the bucket. This will be the temperature change in the water, which can be measured with a thermometer. And this will be the temperature change in the metal, which can also be measured, not with a thermometer really, it would be more of a thermocouple. And this is the mass of the metal. Okay, so by knowing these values, which we know all of them, we can solve for the specific heat capacity of the metal. Okay, so this is what we're going to use right now. So let's say if 0.05 kilograms, this is from page 315 in your book, the example we're about to do, in case you want to reference it later. If 0.5 kilograms of a metal bolt is heated, of metal, sorry, and again it's an unknown metal, is heated to an initial temperature, let's see, an initial temperature of where is the temperature? 81 degrees Celsius. So I'm doing the problem backwards. In the problem, they have you solve for the temperature, but I want to show you guys what it was really used for. So we're going to solve for C. They give you C in the problem, and they give you this C, and they say, find the initial temperature of the bolt or the metal. But what I'm going to do is actually do it the way it was originally devised. Okay, so they talk about how it was devised, but then they do the example backwards, which kind of bothers me. So if 0.5 kilograms of metal is heated to 81 degrees Celsius, and it is dropped in 0.15 kilograms of water. Again, what is this? This is a mass. Remember, it's not a volume, which is very odd to think about. Because when you talk about water, you would talk about a volume, you know? 2 gallons, 3 gallons of water, or 12 ounces of water. You wouldn't normally say kilograms. So maybe at some point we should figure out what this number is in volume so it's a realistic problem for us. In 0.15 kilograms of water with an initial temperature of 18 degrees Celsius. So think about this for a second. Oh, no, let's change this up. 21 degrees Celsius. The temperature of the metal is 81. Temperature of the water is 21. So clearly, where's the heat going to flow? Metal to water. Again, heat always flows from high temperature to low temperature. Metal to water. Okay, let's say that the equilibrium temperature of these, not objects, but of this, let's say, of this combination. Whoa. (25 degrees Celsius). Find the specific heat capacity of the unknown metal. Okay, of the unknown metal. Keep in mind we know the C value of water. I'll write it down just so you guys are all clear about that, but we know it already. It's 4186. We did it last class. Okay, that was the specific heat capacity of water.
I felt like it changed this a bit.
So, since we're trying to find that C value on the left-hand side there, we can determine from this problem by just solving for C. So we've got our formula at the very top of the board there. We're going to solve for the C on the left-hand side. If you would like to, you can plug all the numbers in. That's fine. Again, I always encourage you, if you want to do that, you can. But I would always solve for the variable itself. So if you want to plug in your delta T's, plug in your C for water, your mass of water, your mass of the metal, your delta T of the metal, you can do all that stuff. Okay? So, how do we figure out the delta T's? Let's start with that, because that's the first part we want to think about. For the metal first. What is my starting temperature of the metal? 81?
Degrees Celsius.
Yep, you're right, Karen. Initial. Okay, there's my initial temperature of the water, of the metal. What is the final temperature of the metal?
25.
Why 25?
Because that's the equilibrium temperature.
Very good. And equilibrium means that both the metal and the water will be at 25 degrees Celsius after this operation has undergone. Okay? After this operation is undergone. Okay, so the combination of the two is going to be 25 degrees Celsius. So what happened to the metal, guys?
Lower.
It lowered its?
Temperature.
Good. So it lost or gained heat?
Lost.
Lost heat. Lost heat. Lowered its temperature. The metal. Now let's get to the water. We'll do the water in green. The water starting temperature is? 21. Yes, very good. The water's final temperature is 25. They're both 25 there because it's equilibrium.
No.
So what happened to the water's temperature? So it gained. It gained heat. It gained heat. So the heat that the metal lost, where did it go? Into the water. That's the idea here. Now, remember, when does this work only though? When will this only work, this kind of an experiment? You got to think logically now. This is mathematical. Now think realistic. If I did this in front of you, what would happen really? Okay. Okay, solid liquid would lose mass, both correct. A little bit of mass, the water would. Yeah, it would evaporate some of it, right? Wouldn't the steam really come off? So for this to actually work, and for these energies to be perfectly balanced, what does it have to be in? Yeah, like a closed container or a vacuum, in a sense, but a vacuum of heat, not a vacuum of air. So you would have to put it in an insulated container that would not let any heat escape, which is almost impossible. So you always account for some sort of deviation, okay? Because think about it, you stick that metal in there, it starts to steam. You're losing energy, right? You're definitely losing energy to the surrounding environment, okay, to the ambient environment. Still on the sword, yep? Okay, but this is just metal. All right, so we've got our delta T's, right? Now we got to think for a second. The T value of the metal went from 81 to 25. Very good. So it's going to be negative in there. Because remember, if you want to find the change, final minus initial. Here's the final, here's the initial. So for this value right here, you're going to do 25 minus 81. So it's going to be negative, which is fine. Because look, the two negatives will do what? They're going to cancel each other out. And that's the negative that we applied in the formula right there. That's where that negative comes from. If we look at the delta T over here, the final temperature of the water was 25, but the initial temperature was 21. So this is fine now. So this is a positive for delta T over here, but there's a negative in the front. So we're still going to have a negative, which will cancel out, yielding a positive. Because the specific heat capacity has to be positive. If there's no negative values. It'd be like saying the friction constant is negative. Remember that thing, mu? The mu, the ratio of the normal force to the frictional force? Okay? The one that looked like a U, yeah. It told us how rough the surface was. It was always positive, it was never negative. Okay, it was never negative. So, in this problem, we want to think about the fact that we have an unknown quantity that can be measured experimentally. Okay, that's the whole point. So we know the C of water, that's 4186. I'm dropping units right now. The mass of the water was 0.15. There's a negative in front. The mass of the metal was 0.05. And we don't know the C. So solve for C. Again, I encourage you to solve analytically first. So solving analytically, I'm going to put that at the bottom. You get the C of the metal is equal to negative MC water, 8M water, C water, delta T water, all over M metal times delta T metal. Okay? Again, if you solve that original equation for the C, that's what you're going to get. You're going to get negative MC delta T for water over M delta T for the metal. Again, how does that work? We go back up, we take this quantity and this quantity, we move them over by division. Okay, so that's what you're going to end up getting, plugging in your numbers. What do we end up getting here?
772. I got 837.
Okay, so we got two different answers. I need another person to verify that. I think it's 897, to be honest.
Oh, yeah.
Okay, check what your work is.
You good? 897?
899 or 897?
897.
897.
Yeah.
Okay.
That's the second one.
And remember, the value for C has units of kilograms per, joules per kilogram Kelvin. And instead of Kelvin, you could put degrees Celsius, it's fine. It's the same thing your book will have. So we're able to figure out the specific heat capacity of this unknown metal. What we could do is wonder, well, what kind of metal is it? We could then go to a table of known metal values and see which one it matches up with, and then try to see, well, if it matches up with 5 metals, then we have to start looking at other properties. Is it brittle? Is it ductile? What is its boiling point? What is its freezing point? All that kind of stuff. So let's think, maybe there's a metal that has this number. Aluminum. Oh, it turns out to be aluminum. Aluminum is 899. So the unknown metal in this problem was pretty much aluminum. Any other metal that I have on here, copper was 387, mercury is 138, lead is 128, gold is 129, iron is 450. So the only one that comes close here, the only one is aluminum. What did you miss, Mercury? Okay, the only one that works for this is aluminum. So we're going to do another problem now. We're going to do another problem, so we're going to try and figure out exactly what metal it is again. Okay, I'll put up a table so you can see the values and you have to determine which unknown metal is it.
Can you go down the hill?
Yep. Can I borrow
You just
something?
wanted to see if it's still there. No, you can. I know Mr. Smith wanted to go.
Am I going to go? Yeah, I'm going to go to Hub Shack.
So mad at you. Who I look like so much?
You know, you can show babies and have
I'm not working out. Listen to me say,
No, it's not embarrassing. It's just a picture. Yeah, you can be the you ain't gonna have nobody else.
You got anybody? Hey, come here. You got Sue. Come here. Come here.
Asian kids, I took all these.
But I don't know that. Because his mother coming from bed. They about to take me to go get my dad.
Oh, I know what this is.
So the girl, she was like, how come? She was like, actually, you had 2 syllables and stuff.
I That's what I was trying to see if they was gonna let Nicolas come, but.
Yeah, it's true. Everybody always comes on here.
That's not bad. They'll be crazy. He started talking to the team other night with his brother. Yeah, I'm glad I know him.
He started that?
You think that's good?
You know Poppy?
So while we're talking in that video.
All right. So, your goal now is to figure out exactly which metal I'm talking about, okay? By figuring out the specific heat capacity of that metal. So let's say we have, again, an unknown metal of 10 kilograms is cooled from
Don't we need our book to find it out?
I'm going to put the table up for you so you can see which ones to choose from. It's cooled from, let's say 100 grams, not 10, let's say 100, sorry. It's cooled from 500 degrees Celsius to 200 degrees Celsius by 20 kilograms of water. That doesn't make sense, right? How do you have 100 kilograms of metal and 20 kilograms of water? That's stupid. If I drop another zero, it's going to increase it. You can drop a zero there. Yeah. Okay. Change it up once more. Sorry. All right. 50 to 20 and 10. Let's do that. Okay? That makes it easier. The temperature of the water goes from God bless you.
Some people judge you by work, they judge you by who you work with, like super board.
Do you not have one? Not really. It's more like an end of the year celebration. They're like end of the year. So guys, I changed some stuff. All right, this is the final one. Yeah, you just have more end of the year celebration. It's actually pretty fun. I think they're like a little more fun than private baby. It's fun. I'm just saying. I think you like fun.
It's not really Six Flags.
I have no idea. I'm sorry. Pretty sure it's been announced all week.
Why would they do that? Like, they would just go for prom.
I just told people to trying to get what is it?
I heard you just got fill out the permission slip and then go talk to Miss
I heard.
Hey, just during the application, she said that she would have her the spot reserved.
Yeah, but if you guys do that, make sure you have it for Monday because she's not going to take much of that, I think. Somebody did ask her that the other day.
I asked her for a opportunity on Monday, she said yeah.
Yeah, but I don't think anything after Monday, you're going to lose your spot, I think she said.
What?
Go ask her.
Why go last year?
Oh, sorry. No, that's it.
Yeah, it's a king for me. I love the king.
Oh, 10.
Yeah, I'm like, take out.
That's what I was trying to do, but it wasn't working at first. I think it's working.
Yeah, like, people gotta.
Yeah, which God?
Remember, guys, it's the same problem now. You have to figure out what the new metal is. You know the C value of water is 4186. You're going to need it. Use the last problem as your template to help you here. If you really need help, ask the person next to you for a quick step, but try to do it on your own.
Teacher, can you help? Right.
Nobody knew how to respond to that. That's why I wrote it. I did.
You should get a petition. Like, even if they can't go to prom. It's literally, how do you gonna find a new school in 4 weeks? Don't do that. Because half the public schools don't even take theology as a credit, and he still needed a Spanish credit.
Yeah.
What's the-
Supposedly, you're supposed to be in the next
And if you took Latin, you should need another credit. Because I heard her school wouldn't let her let Latin be one of the credits.
Well, no, her school just worked her. The school found we had that.
I still had to go back a grade because he wouldn't have enough credits. Yeah.
Now he got work, because Timothy is slow. And they go to the same
So
school.
Timothy is the smartest thing.
No, son.
Oh, that man is stupid.
Son, no, son. That man is not smart.
That man is not
Trust me, son. I know him since 6th grade. I see the report card. She not that smart.
I didn't listen to the radio. Looking at his face, son. I didn't like
Yeah, she said she hated his face.
Oh, Timothy did?
So he's
he would not stop following me. Like I said, hi, this would be nice, son. He literally followed me like 3 blocks. He's like, did I still go this way? I was like, no, I'm turning this way. I had to do it. He was like, why you even start talking? I was like, you trying to be nice, huh?
because you know that
Yeah,
he
he
was
like,
like,
followed it, son. Just talking. I was like, yeah, I heard you stalk Liz. He's like, I ain't stalk her.
son, she
I just followed her home.
He did?
No, I'm like,
I'm gonna say,
I
if somebody stalk you, someone call the police. Like,
I had a stalker.
Nobody's-
When I was in 8th grade, every time I got off the bus, he would stay away from me. I got rags up, but I got me crushed. I ain't telling for like 3 weeks.
got on the bus, silver ring.
He was waiting for
yeah, Chris.
Timothy? You gonna be a neighborhood?
Nah, dude, Mike. He found me.
But everybody sounds like that. I didn't see it.
Alright, this is Mr. Hellfail. This should be 100.
I was on the
That's why you're not going to get a number that works.
Me too.
You get the right answer, but it's not going to be on the list. And it turns out we're not actually getting a medal here, we're getting something else, but it is the right number.
If I even people like soft city.
How did that not happen?
So should we change the medal?
Yeah, yeah. You could just call this substance instead of metal. Substance. Let me know when you get an answer, just raise your hand, I'll come by and check it.
No.
Just tell me, I need the number. Tell me the number of C and then I'll tell you what the substance is.
I did. No, I was not there like I did.
I can shoot it in that one?
Go to the left one, I think. I don't know if those are recyclable.
Like that.
Now, were you aiming for both or you aiming for one?
I was aiming for both.
All right.
Because you said go to the left one, so I don't know if that was recyclable. But he said aluminum.
Yeah. Alright, I'm gonna bring up the table now, so you guys can see the table.
If it wasn't for this school, I could have won. Like, because of the coach, I didn't take him seriously, so I didn't practice.
Hey, no.
So my game.
Hey, Britt, that basketball coach is so mean. I was at the basketball practice one day. Yeah, I was at the basketball. Yeah, he was like, I like the girls for Christmas. Like, so, oh my God! They started laughing about it. It sounded funny. It's like, girls for Christmas.
You know how you tell me?
Like, so you know, he's supposed to be getting out of jail cell. It's like, what are you talking about?
His kids couldn't get
He tried last, he was like, yeah, where you be at? What you supposed to, yeah, I'm gonna patrol around there. You can't leave your business, boy. You can't leave your little square.
Try to figure out which one it is, please.
It's silver. Now I gotta rewrite it.
That's how you up there.
Yeah, basically.
Every time you see
I got it. Then I'm multiplying back to no, it was really, I didn't get it from,
the masses are different. One side is water, one side is water.
Yeah, the masses are different. That's the problem. It's a very high mass of the object.
Look like the government? Yeah, they do.
Alright, here's what I want you guys to do this weekend. Write it down, please. Page 316. Problems. Try all four, please. Problems 1 through 4. I ended up getting glass. It should be around 8:37.
I didn't get 837, so I
Change the mass. Again, guys, this weekend, page 316, problems 1, 2, 3, and 4. Each problem is going to be testing you to find a different variable. Sometimes it'll say find C. Sometimes it'll say find M. Some of them will say find the final temperature. So use the formula from today to do those 4 problems. They will challenge you. Do not give up. Use the formula. Solve for the right variable. Make sure you read the problem. Be careful. All right.
You said that every time you have homework. They will be hard.
I'm telling you, that's what this is about. It's made to make you think. So I'm just telling you now.
Hard.
You know what I'm saying?
When I go to class, you get
For what? You want to see? The rest of the year's going to be hard. The rest of the year's I'm not yours. My is every day is something else. Crazy stuff. What time,
60 seconds.
I'm just putting it over. Because me and Mario are going to go first.
No, she doesn't. She's like,
I want to go home so bad.
Next week?
I heard it's a letter that came with like
But actually, like, wonder why? Wonder why? Because the schools actually count like they count like exam days.
She didn't count.
Yeah,
So now I think it's like 3 more school weeks and finals.
So they got like.
I tried to.
Now they would say that. I don't know.
The class is on
Mark.
Next week is on after when APs are over, you know? Okay. For copies, please attendance. I didn't know where you were. Nice work. Thank you.
And,
Should probably stop recording,
I
right?
just remembered it when you walked into the room.